Speech-to-text recognition system helps users transcribe audio input into text output. It is very useful in our daily life, like transcribing a lecture into text form for students to better understand the information. The problem is, the speech-to-text recognition system can only service one user at a time. How to deploy the system to allow more users to access the system at the same time? This project makes the speech recognition system highly available and scalable so that many users can access the system concurrently. The system was designed with two key pieces of technologies, Docker and Kubernetes. Docker is a containerization tool which packages the speech-to-text recognition system into a container image. Kubernetes is the container orchestration tool. It manages containerized workloads and services, which allows for decorative configuration and automation. It is an excellent tool to manage the speech recognition application containers to ensure scalability and as little downtime as possible. A robust system architecture is designed to handle high workload. The system can be scaled dynamically according to the number of user requests. There's a master service which accepts users' requests and passes them to the master pods for further processing. When a user connects to the system, the master pods will take in the user's audio input and transmit them to the corresponding worker pod for decoding. For a proof of concept, 50 long-running worker pods of the same language model are configured where they will take in the audio input and churn it into text output. What happens when there is little or no worker pods left to decode incoming requests? This is when the master pods will come into play and spawn new worker jobs. Master pods keep track of the number of available worker pods and trigger the spawn of new worker jobs when there are less than 5 worker pods available for each language model. Worker jobs are transient as they will be recycled after completing the decoding jobs. The beauty of this system architecture is that the system scales the number of nodes in the Kubernetes cluster dynamically according to the number of incoming requests. When the existing nodes have insufficient computing resources, the Kubernetes cluster will trigger a node scale up to increase the amount of virtual CPU and RAM available to initialize new worker pods. Conversely, the Kubernetes cluster will constantly scan for inactive nodes and scale down some of them to conserve the number of nodes used. All of these are done automatically through clever configuration of the Kubernetes cluster.